This is the next video of talking about inertial and non-inertial frame of reference. So this is a very important concept concerned about pseudo force is also coming, because many of the questions which is little bit difficult can be solved by the concept of pseudo force. So let's talk about this particular point. So coming to this particular section, we will talk about frame of reference. So what is basically frame of reference? From the name itself it is clear that frame of reference is based on some kind of observer. So who is the observer? Now, basis on this frame of reference, I will tell you there are two types of frame of reference, that is inertial frame of reference, and another is a non-inertial frame of reference. Now, how it has been judged, I will tell you this thing. So let's concentrate about this particular fact. If the observer, who is the main part in this particular theory, if the observer is in a particular frame which is at rest or moving with constant velocity, that is acceleration equal to 0, then we will call it an inertial frame of reference. That is, observer is in a frame which is an inertial frame of reference. Now if you recall, non-inertial frame of reference means if the observer himself is in a frame which is moving with a non-constant velocity, that is, it is moving with some kind of acceleration, then it is called a non-inertial frame of reference. To make it more precise, I will explain it in this fashion. So let's think this is the car, and let's say the observer is not inside this one, observer is outside, and the system is moving, and this particular system is moving with acceleration, and this observer is either it's having a constant velocity, that is acceleration equal to 0, or it's at rest. Then we will tell the observer is in a frame of reference which is inertial. Now let's suppose we put this particular observer now the observer is in a frame which is actually moving with an acceleration, then we call it he is in a non-inertial frame of reference. To make it much more clear, we will go through a particular special theory which is known as JV lift case. Now let's see what is the JV lift case is all about. For example, you see, let's suppose the observer is in a particular outside the frame. Let's suppose this is the lift and this is the mass, or this is the object which is kept inside the lift. So let's come out in this fashion. Let's suppose this is a lift 1 and let's suppose this is a lift 2, and here I have a divider to the theory, and let's see, say this is the particle which is kept inside the lift, and this is also the particle kept in the lift. Now the observer is out here, and in the second case the observer is inside this particular frame. Now what is going to happen? See, this is mg coming, and this is normal reaction acting in the opposite direction, that is, and you see the lift is coming down in the acceleration. Now if this man is told to find out the equation for this particular block, the equation will be something like this: mg minus n is equals to ma. So I can tell n is equals to what? Nothing but mg minus a. Now in this particular case, same example, you see this is mg and this is n. Now this man is going to write the equation as mg equal to n. Now you see, for the same particular block we are having two different equations, so it is not correct. One of them must be wrong. Which one is wrong? Now, two of the equation, if we say according to the frame of reference, this is correct because of the fact that this is the particular person is in the particular lift which is coming down, so according to him this equation is correct. So there comes the fallacy. For the same block we cannot have the two different equations. To solve this thing, will come through a concept of pseudo force. Now what is basically pseudo force? If the particular observer is in a non-inertial frame, which he is in the second case, So in this case, we will apply a concept of pseudo force. Whenever the observer is in a frame which is actually a non-inertial, then he have to think about the force which acts in a direction opposite to the movement. So in this case, the pseudo force will act in the opposite direction. Now the equation will be written in this fashion: mg is equals to n plus pf, and the value of pf, or the pseudo force, will always be mass into acceleration of the system. So if I write in this equation, n is equal to m of g minus a, where pf is nothing but mass into acceleration of the system. And here it comes about the concept of pseudo force. So up to this, and the next part of the video we are going to cover about momentum and the questions based on momentum.